This is the aspect of the problem. We have 3 cannibals, 3 missionaries. You have to move all the people from here, from the right side to the left side of the river. And we have a boat which can only use for two people inside this boat. It's not possible to have more cannibals than missionaries at any side of this river. And I'm going to resolve. We have a state problem with missionary and cannibals. Okay, so what is we have 3 missionary and 3 cannibals in right side of the river. Only one boat. With capacity for 2 people. And at any side of the river, the number of cannibals cannot be higher than the number of missionaries. Because in this case, if the number of cannibals have to be equal or less than the number of missionaries. Otherwise, the cannibals can eat. Otherwise, the cannibals can eat the missionary. Okay, this is the problem and the restriction for the problems. We have to move from the left side of the river to the right side of the river, and the number was 3 and 3. And in any side of the river, never can have more cannibals than missionaries. Okay, let's go to resolve that with PROLOG using this state. It's a similar way we did with the problem of the graph and the water. And let's go to resolve in the same way with this state problem. The state problem. Let's go to resolve that state problem with PROLOG. First, we have to define the state. I remember you, the state is like a picture of the situation. I have to write something like state, something inside, to represent the situation or a picture of the problem. What we can put inside here? For example, will it be possible to say, okay, I have missionary in the left, cannibal in the left, missionary in the right, cannibal in the right. No, that will be one solution to have the state. And where is the boat? Where is the boat? That will be one approach to resolve that, no? The number of missionary in the left, cannibal in the left, missionary in the right, cannibal in the right, the number, and the boat. Where is the boat? In the left side of the river or the right side of the river? Okay, that will be an approach. But we can realize we can obtain the number in the left. For example, we can get the number in the left if I know what is the number in the right. No?
Yes.
You can make more simple data state. For example, you think it's really possible to do something like that? Missionaire in the left and cannibal in the left and the boat. Do you think it will be possible to represent with less data inside the problem? Do you think it's possible or not? Only with these three elements. Missionary in the left, cannibal in the left, and the boat. How we can obtain the missionary in the right?
It's the total missionary minus missionary on the left.
Yeah, is 3, no? Minus
Yes.
missionary in the left. And what is the cannibal in the right? Will be 3 minus missionary. Cannibal in the left. No. So with
yes.
with only these three elements, I can make a picture of the problem with only these three elements. So it will be easier to resolve with less information, because otherwise I have to update 1, 2, 3, 4, 5 variables instead of only 3. So always is better to have a state with the minimum information you need to represent. So let's go to choose this second approach. Okay, that will be.
But you have to decide of the missioners and the cannibals in the boat, because we have only a stake for all in the boat and we can't decide.
Sorry, can you repeat?
Yeah, we have to decide in the boat. In the boat there can be both. There can be one cannibal or one missioner or two.
Yeah. That is the second part. Now we only try to represent the state. What is the minimum information I have to put inside to make a picture. Now let's go to resolve this movement. Okay. But for the state, let's go to choose this option. The second.
Yeah, but we can't know the missioners in the right are 3 minus missioners in the left and minus the missioners in the boat.
No, but okay, I know your I understand your question. It's not.
Okay.
Don't worry about how many people are in the bottle, because the boat is only like some transitional situation. I'm not going to pay attention about how many people are in the boat.
Okay.
Only think before the movement, the boat is in one side, we move, and the boat will be in the other side. But don't worry about the situation of in the middle of the movement. It's like, okay, I am moving, people are in the boat, but don't worry about that.
Okay.
It's true. It's true. In the bottle only can go 2 people, so there are no problems. Never can eat the missionaire inside the bottle, the boat. Sorry, inside the boat, because only 1 and 1 it's not possible to have more cannibals. Okay. So let's go to the second part. Let's go to start with the movement. To resolve that, what is the movements? If we think about here the movements, we can say, okay, it's possible, like we did with the case of the carafe of water. We can say, okay, I can move 1 missionaire to the left. No? Move 1 cannibal to the left, and the same with to the right. No, will be another movement. Move 1 missionaire to the right and to the right. and so on, no? I can, and the same 1, 2, 2, 3, and 4, and move 2. I can do, okay, let's go 2 missionaire to the left, 2 missionaire to the right, and 1 to 1. So 1 missionaire to the left, and now 2 missionaire to the left. How many movements we can have in this way? 2 missionaire to the left, 2 cannibals to the left, 2 cannibals to the left, and to the right, and the same, copy the same twice to the right. What is the problem of this approach? Trying to do that approach of make 7, 8, and in this case to the right, and to the right. More options? You have more options?
Yes.
1 and 1, no?
Yeah.
It's move 1 and 1. Move 1 and 1. Move 1 missionaire and 1 cannibal to the right and to the left. And to the left. That's all? There are more options?
No, it's all.
7, 8, 9, and 10. 1, 2, 3, 4, 5, 6, 7, 8, and 9, 10. 10 movements, no? We want to create 10 movements. The program will be too long. It's possible to do that. If you don't have another idea, it's possible to do that. The problem is that you have many movements, no? Let's go to try to think how to, for example, how to create this one. How we can create this movement, like move, 1 missionaire, 1 missionaire to the left. A state before, a state after. What will be the state before? Think about our state is that. This is our representation for the state. What will be the state before? A number, no? Any number. I don't know how many. Missionaire to the left and cannibal to the left. Okay. And the boat, where have to be the boat if I want to move to the left? I have to be to the right, no? If I want to move to the left, the boat have to be in the right side of the river, no? Otherwise, it's not possible to make this movement. It's not possible to move to the left. The boat have to be in the right side of the river. Okay, what happened after that? After the movement? What will be if I am moving 1 missionaire? What will be the result? Missionaire to the left. 2 will be a missionaire to the left plus 1. No? And what will be the next state? Will be missionaire to the left 2 and the same number of cannibals. Cannibals to the left, because we don't move any cannibal, only 1 missionaire to the left. No? That will be the implementation. Only modify the number of what I have to check if that is true. I only can move one missionaire to the left if missionaire to the right is 3 minus missionaire to the left if missionaire to the right are greater than 0. No? Otherwise it's not possible to move one missionaire to the left because we don't have missionaire in the right side. No? That will be one implementation for this movement, and I have to create 10 of these movements. But I have another solution, a little bit. That will be the first approach. But let's go to try to first approach. Let's go to try to do in a more smart and simple way. The second approach is, okay, instead of to write 10 movements, different movements, let's go to modify that. What do you think if we make the movement and say, okay, move a number of missionaires, a number of cannibals, in which side? Or to the left or to the right? Okay, let's go to move a number. The movement, instead of be only this name, let's go to put a predicate or a structure of this with 3 variables inside. Let's go to move a number of missionaires, a number of cannibals to the left or to the right. Or if left or right, if you prefer. Let's go to move to the left or to the right. Okay, and now the state before will be a number of missionaries to the left and missionaries to the right, and the both have to be, for example, if I want to move to the left, the both have to be where? In the right side. In the right side. Okay. And what is the result? What will be the result, the state after the movement? What will be the state after the movement? We can calculate. It's possible. Move to the left means increase missionaire to the left. 2 is missionaire to the left plus m, and cannibal to the left 2 is cannibal to the left plus c. Is the number of cannibals I'm gonna move to the left. Okay, so the new state will be missionaire to the left 2 and cannibals to the left 2. Sorry, I make a mistake here. It's missionaire and cannibal to the right, to the left. Sorry. Okay. You see the idea? Is instead of write 10 different movements, let's go to write only 2. Only the movement to the left and movement to the right. If I copy that, now I can say, okay, let's go to move to the right. To move to the right, the both have to be in the left. In the left side. What means how we can calculate the new number.
I have a question.
Yeah.
But in this case, how many people can stay in the boat?
In the boat, exactly the same. In the boat, have to be only
two.
Only two.
In this case,
yeah.
Two.
It's a restriction of the problem. The movement.
Yeah, but in this second approach.
Yeah.
You can't have only two people on the boat.
Yeah.
Or
so m plus c, the maximum, m plus c have to be 2. Okay. Will be 2 missionaires, 2 cannibals, 1 missionary, 1 cannibals, and that's all. 2 missionaries, 2 cannibals, or 1 and 1. We have 3 options here: 2 0, 0 2, or 1 1.
Yes, but for do this restriction.
Yeah.
Where you do to put this restriction?
Yeah. Now. Okay. Perfect. Good question. Good question. And let's go to resolve before answer your question. Let's go to resolve to finish that. Let's go to calculate this new number, and after that, let's go to resolve your question. So, missionary to the left 2. We are moving to the right. So tell me, missionary to the left. We are moving to the right. So what happened with the missionary or cannibal to the left? Is minus m. No? We are moving from the left to the right. So we have here the missionary in the left side. We have to delete this number. And the same with the cannibals. It's cannibal to the left minus c. Yes or no?
Yes.
Yes, okay. Nice. Let's go to...
question,
yeah.
Sorry.
Yeah.
To line 57.
Yeah.
Do we need, like, in the state after, we need the boat at the right position?
Yeah, exactly.
Okay.
Sorry. We move from the left and the state at will be the right, exactly the same here. If we move to the right, start in the left and at the end the right. Okay. Sorry. Move to the left. The same here. At the left. Okay. Sorry for the. I forget to put this the boat in the state. It's very important because otherwise we don't know if it's possible to move or not to the left or to the right. State. Okay. Let's go to put, for example, here. Okay. And now let's go to answer the question of Christian. It's like how we can check. Okay, let's go to create and move. The option for move. Move is possible. The possible movement are 1 and 1, and doesn't matter about the boat. That will be one option. Move, I can choose 0, doesn't matter about to the left, to the right. Move will be 0, 2, doesn't matter about, and that's all, no? 1 1 to 0 0 2.
And 1 0 0 1, no.
Oh yes, yes. It's okay. Possible. Yeah, it's possible. It's not possible to go with the boat empty, but it's possible 0 1. Yeah, exactly. 0 1 is another option. and move 1 0, sorry, and 0 1. Okay, that is the possible movement. So perfect. We need one more thing. Is we have to check when it's a valid or not valid state, because here we add and delete missionary and cannibals, but what happens if I don't have missionaries to move? Probably I will reach a state that is not valid. So let's go to right here. What means a valid state? What are valid states with the restriction of the problem? For example, a valid state in the left side is 3 and 3. It's a starting point. 3 and 3 is a valid state. What more? Valid state. What more is valid?
But in the first case, valid state 3 3 and right side, left side is impossible. No.
Sorry.
In the first valid state.
Yeah.
Is 3 3 right side, because left side is impossible.
Oh, the state, we're representing the state only with missionary in the left side. We have to calculate the right side. So what means that? That means if we have 3 missionaries in the left side, we have 0 in the right side. If we have 3 in the left side, we have 0 in the right side.
So the both is in the left side.
Yeah, doesn't matter. Don't worry about the boat.
Okay.
Don't worry about the boat, because it's possible trying to resolve the problem. The boat will be sometimes in the left. Doesn't matter. It's not.
Okay.
This is not really a problem to resolve this problem state or this game. We only have to verify when a state is valid or not. So this is the valid state. This is a valid 2 with all the people is in the right side. That is the final state. It's a right state. What more? What more is valid? What more you think will be valid? It's not any case when the number of cannibals never is higher than the number of missionaries. So, for example, 1 missionary and 1 cannibal. Do you think is in the left? Do you think it's valid or not?
Yes.
Yes. Why? Because the other side are exactly the same. They are 2 and 2. So that is valid. Other option. State is valid if you have 2 and 2. No?
Yes.
The other side will be 1 and 1. That's true. What more?
1 and 0, 2 and 1.
Valid state 1 and 0. That means in the other side will be 2 missionaries. I think that is not valid. It's not valid. That is not valid because in the other side will be 2 and 3. So that is not valid. What more you think will be valid? Option. Valid state. 3 3 0 0 1 1 2 2. What more? I'm gonna let me see. I have the code. Wait 1 second. I'm gonna take the list of valid states. Okay, you're not here. Okay, I think this is the full list. In this case, okay, in this case, you have a no valid instead of valid. Probably will be shorter the list. Not valid state. Probably the list will be shorter. I don't know, or easier to not valid. Not valid state. It's the same idea, but probably it's shorter with not valid. Okay. Not valid state. This is the not valid state. It's not valid to have. Probably will be more or less the same, no? It's not valid is 2 and 3, 1 and 3. Okay. Is not valid because that here there are more. Is in the left, 2 and 3. That means will be more cannibals. 0. Here there are one more. It's not valid. One more. It's not valid. It's not valid. It's not valid. It's not valid. I think that's all. Okay. 1, 2, 2, 1. Okay. As you prefer. You can do with valid or with not valid. What you think is whatever you want. Okay. Okay. Next. Now we have not valid. Let's go to leave only not valid. Okay. And now next step. Let's go to. We have the movement. Let's go to create the path to the solution. 3 is path to the solution. What is a more simple case? What is a more simple case for the path? The most simple case is the initial state and final state. Oh, remember, the path we have initial state, final state, the visited states, and the path. This is an input. This is an input, this is an input, and this is an output. And this is true if path unify with the list of movements to go from initial state to final state. Okay, without repeating visited states. Okay, you remember why we use this visited? The idea of this visit is not repeat the same image. Like, think about, for example, you have the cannibals and go one and back to the same position, take one missionaire from right to the left, and then back to the right, and always doing the same. So we don't want to repeat the same state. So to try to avoid this repetition, we use this list of visited states. So in the case of path, what is the most simple case? If initial state and final state are the same, and we put the same variable into in initial state and final state. If the initial state and the final state are the same, what is the list of movements I have to do? What will be the solution? The list of movements.
An empty list?
Yeah. Here I'm gonna write one example. For example, it's like a path to be something like a list of move 1, 0 to the left, or yeah, to the left. For example, another move 1, 0 to the right, and so on. That will be something like that. Will be the solution. A list of movements. Okay. In case where this initial state and final state is empty list, as said Colin, the solution will be an empty list of movements. We have to do nothing if we are at the end, initial state and final state are the same. And visited, we write here an empty anonymous variable. That means, okay, doesn't matter, because if we are at the end, we will not repeat any state. So doesn't matter what we have if we are in the final state. Okay, let's go to create the recursion. From initial state to final state with a little visited. Let's go to leave the result to the end. Let's go to try to find a movement. Let's go to move a number of missionary and cannibals. Let's go to move missionary and cannibal direction. Let's go to move and from initial state to a new state. Let's go to call the new state, for example, temporal or auxiliary, or if you prefer aux, whatever name. Let's go to move to an auxiliary state. What we have to do after that? We have to check if this new state is a valid state. In this case, we say not valid. Aux. This is the double. It's like this is not. This is the negation. So that means it's not valid. The negation that is valid. It's a little bit recursive, but that works. Okay, it's not valid. It's true. That means this state is valid. And now let's go to sorry, and I need one more thing. because to limit the number of movements, let's go to move missionaire and cannibals in this direction. Okay. Why we put that here? Because in this way, Prolog only are going to check these options right here, not all the options. We're only gonna check these options here. The 1, 1, 2, 0, 0, 2, 1, 0, and 0, 1. There are no more options here. So first, try to take one of these values, and after that, try to move this number of missionaries and cannibals. Okay, this is only to limit the number of options here. Only take here the valid position or valid number of missionaries and cannibals in the boat. And to finish that, a path from where to where. I make a movement from initial state to auxiliary. And now, what is the path? From where? Where state? Can you tell me? From where we have to try to find the path? I'm gonna give you the idea again. It's like, okay, I want to find a path from one initial state to the final state. What is the trick here? Okay, let's go to make a movement from, let's go to move from initial state to any position, any new state. Let's go to call this auxiliary, for example. Let's go to make a movement from this initial state to another state that we call aux. And then let's go to find a path from aux to the end. Okay, let's go to write a new path from aux to the end, to the final. Okay, so let's go to this path for initial state and to final state. Let's go to move first one movement to anywhere to any new state, and after that let's go to create a path from aux to final, and that we will have the full solution. Here we have the induction. This is L-1. This path have one movement less than the full path. Okay, here we have the L-1 of the induction. Okay, nice. So what I have to put here? What I have to put here? Can you tell me?
That is the last, the final state, or not, Prof? Sorry.
This is, I want a path from initial state to final state. Okay.
Okay. Okay.
I make a movement. Make a movement here from initial state to auxiliary state. Now we have a new situation of the problem in aux. We are here. And now we want a path from where?
Then you have to write there aux.
Yeah.
Then fine.
Yeah.
Then visited plus aux.
Exactly.
And then, yeah.
Aux is the new state we visited. We have to add visited. And here I have a path. Whatever. I have a list of movement to go from here, from aux to final. but I want to obtain the path. I want to obtain the path from initial to finish. So what I have to do to this path of n-1 is 1 minus, because I have one movement minus to the solution. What I have to do to this path to obtain this full path? Remember, that is a list of movements. What is the movement I did? It's this one. This is the movement. I need to go from in to out. So I have this path, list of movement to go from here to here. I only need to add this movement. No?
Yes.
It's like move M and C the direction to the path. It's okay?
Yeah.
Yeah. Okay, let's go to check if that works. And I have to put here some comments because it's not part of the code. Okay. Here. This is a second approach. This is our valid approach for us. It's more simple. We only define 2 movements instead of 10 movements. So our code is more shorter than okay, this that. Okay, I think this now it's okay. Here is start the code. Okay, let's go to load this code in PROLOG. And okay, there are no errors. Let's go to this thing. Move. Sorry, move. This is the 2 movements to the left and to the right, and the listing of the path of the base case with when initial case and final case are the same. Doesn't matter here about the visited, because we cannot repeat nothing because there are no more states here. And this is the recursion. Okay, how we make this call? What is the initial state for us? Go to find a path from the state. What is our initial state? Is 0, 0, and the boat to the right. No?
Yes.
What is our final state? Every 3, and doesn't matter about the boat, but will be to the left at the end. But and what at the visited state at the beginning?
No.
What is the list of visited state at the beginning? Empty list.
Only 0, 0.
Or yes, you can put this state or empty list. That works in both cases. Okay, let's go to leave only empty list. Okay, and let's go to the path. Give me the path to go from this state to this state with not visited state at the beginning, and let's go to obtain the path. Okay, we have some mistake here. Let me check, because I'm taking a lot of time. Let me check what happened. Let me check. I'm gonna tell you how you can detect this type of problems. We have a graphic tracer or debugger. If we want to use this graphic debugger, we can use use this predicate as here we tracer, and now trace, and now next after trace, the next predicate execute will be executed step by step. Let's go to see what happened, and try to see what is the error here. Okay, initial state we have here. Sorry, I can't. I don't know how to change the font settings. Oh, I think it's not possible to change the font. Okay, can you see? Initial state is 00 right. And final state is 33 whatever. So unify here because in initial state and final state are not the same, so only unify here, and we can, if I click here, I run a step by step. So move what happened here? Okay, whatever.
Prof.
Yeah.
Maybe the error is in the not valid. Because state not state. I don't know if.
I don't MC. I have the problem is the direction. What happened with the direction? Direction is the left. Now we have the direction here. It's not valid. The aux is a valid state. Yeah. Next, it's true. Not valid. It's false. So that is a valid state. That is true. And now let's go to find a new path from aux state from 1 to the left. And now let's go to try to move 1 in this case to the right. Okay. That state is valid. Okay, that's okay. That's okay. Perfect. And now let's go to try to move again 1 and 1. But now the problem is the visited state. We have these two states is 0, 0 and 1, 1. So what happened now? Ah, I forget here to write not visited. Sorry. The new state have to be valid and not visited. But remember, aux of visited. Okay, this is the problem here. I forgot to put that. The aux, the new state, have to be not to be a member of visited states. You understand that? You understand why? Because otherwise it will enter in an infinite loop.
Yeah.
So okay, perfect. Let's go to finish that, because we are creating the visited states, but we are not checking the new state are not here. So we will always do it the same. Let's go to see what happened. What happened is, as I told you, I always repeat the same 1001, 1001. here 0 1 0 1. We are moving one and one missionaire, one cannibal and one missionaire from left to right all the time. You see? 1 0 0 1 1 0 0 1 1 and so on. We will repeat this loop always. So now let's go to finish that. Okay. And now make listing. Sorry, I'm going to open again Prolog. And now file consult missionaire. Okay, let's go to make a listing of the new path. And now we have this line, this is a very important line. Check the new state is not in visited, are not included in visited lists of a state. So now this is the path from 0 0, the boat on the right side to the 3 3. So we have another error here.
I think it's because you wrote estate and not state on the non-valid movements.
Okay, what's that? Where? Which line?
On up.
Yeah, sure. Yeah, perfect. Thank you. That's all. This is the problem of Prolog. Can detect that when there are no errors in the code, but it's very difficult for Prolog to detect this type of errors. Okay, nice. Thank you. Nice. Listing not valid. Okay, nice, perfect. Okay, some error more, but we have to check that is okay, not valid, it's okay, the state. Can you see another error or not? Move. Is it? Okay. Let's go to do again this step by step. Sometimes we need to, if you have some error of this type, we have to try to make it step by step, trying to find this error. Okay, let's go to C now. So let's start here. That's okay. First movement 0 0 1 1. It's the same as before. Let's go to see what happened now. Try to make this movement. It's a valid state. Aux is and one already visited the state. Okay, but now that is false because these states are included. So we have to check another option. Try to move 2 is a new option to 0. not valid state. Have a not valid state. 02. The new state is 02. 02 is not valid. Member. Okay, we have new 02. Is a valid state or not? So all the missionaire to the left is okay. Perfect. Now we have -1. This not. I think I know what is a problem. Let's go to make one modification here in the code. I think the problem is they are making many bad options. So we can try to cut the options, saying, okay, if you want to move, missionaire to the left, you have to. So missionaire to the left. Or the new missionaire have to be. We have to check. Okay. ML2 have to be greater than 0. And cannibal left 2 have to be greater than 0. And left 2 have to be equal or less than 3. And cannibal left 2 have to be, I think only with that we could many options, and probably will be finished. Cannibal 2. Let's go to check now what happened. Okay. Probably the problem is here we are creating bad options, like with no negative values here. This is not a valid state. Okay, they are including not valid states because we are not checking that it's not valid, and we have no option to check that. Okay, can you see? We have here a state with negative numbers, and not valid, we don't check that. So we have to include these two restrictions here. Okay? Okay, nice. Let's go to check again. Okay, that will be very interesting for you when you are trying to create your project or develop your project. Try to or can execute step by step. Sometimes can help you to try to detect some errors. So okay, nice. Make. Let's go to close that and open again. If you see many errors in Prolog, is better option to close and try to open again, load again. Okay, there are no errors. Listen, move. Now we have these new options, checking that we don't have here negative numbers or greater than 3. Perfect. Now okay, now we have another solution, different solution, but there are something new here. Let's go to see again what happened. And now probably the two first options have to be exactly the same, 1 1 and 0 0. You have a negative number here. It's okay. Oh, sorry. Did you? Sorry. Of equal to 0. Equal to 0. 0 is not a valid option too. Okay. Go to close that. Open again. File, consult. Okay. Now yes, we have a solution. Let's go to check what is the length of this solution. The solution is write the path. This is the solution. Start here, one to the left, and the last movement is this one. Okay, let's go to check what is the length, because we want to obtain the shorter solution. Length, the path L. The length here is 13 movements. Let's go to check if there are solutions with less than 13, with 12. No, there are no solution with 12, only with 13 will be the, and with 11. Oh, yeah, one with 11. It is shorter. Let's go to check if we have a solution with 12, with 10. We have no solution with 10, and not with 9, and not with 8. So we have only a solution with 11. Let's go to check the solution. Write path. We have to use this predicate because here the solutions are not complete. We need to use this predicate to see the full solution is here, from here to here. Let's go to check if that works.